this is Sadbi. The topic of our discussion in this video is limit and continuity. I will begin this video from this quiz problem. Whether or not the limit of the function depend on the value of the function. Pause the video for 1 and 2 minutes and give a thought on this question. If you don't know the answer of this question right now, watch the rest of the video. I hope you will find the answer there. Before I give you the definition of the continuity, first look at the definition of discontinuity. A function is a discontinuous if the function is not continuous, or in other words, if the graph of the function has a break. So there are three different ways the graph of the function can have a break. The first one is it can have hole, it can have jump, the function is a break but it's a jump, or it can have an infinite jump. So we will classify the discontinuity of the function in three different ways. If the graph of the function as a whole, we will call it is a removable whole. In this situation, the limit of the function will exist, but it will not be equal to the value of the function. The second is the jump, which is a finite jump. In this situation, the left limit exists and the right limit exists, but they are not equal. Infinite jump if the left limit or the right limit is infinity. Let's look at another example. In this graph of this function, it has a finite jump at 1, 3, and 5 because in all these points, the left limit and right limit exist, but they are not equal. Here is another example, and where we can see that the limit, if I calculate the left limit at 0 of the function fx, which is infinity because the function is keep going up to infinity. However, the limit at 0 from the right of the function is approaching to 2 because the graph of the function heading towards 2. So there is an infinite jump because there is an infinite distance between 2 and plus infinity. So this is called the infinite jump here. However, here the left limit of the function at 2, limit x approaches to 2 from the left of the function is approaching to 6, and also the right limit as x approaches to 2 from the right side is also 6. So limit do exist, but the value of the function at 2 is 2, which is not equal to the value of the function. The function will not be continued if the limit is not equal to the value of the function. So now I can give you the definition of the continuity. A function is continued if it is not discontinued. And if the function is not discontinued, it means the limit of the function exists and it is equal to the value of the function. Or in other words, in order to be function continuous, it has to satisfy these three conditions. The first, the limit of the function must exist. That will basically that will exclude all the possibility of the function can have a jump, and the value of the function exists. And the third is it should be is equal to the limit should be is equal to the value of the function. So if these three conditions hold, then we will say the function is continuous. Limit should exist, the value of the function should exist, and it should be is equal to, the limit should be is equal to the value of the function. If only the left and right limit exist and is equal to the value of the function, then we will say it's a left continued or it is a right continued. Here I have one example where we will check whether the function is continuous or discontinued at point x is equal to 4. So let's begin this example first calculating the limit of the function at x is equal to 4, which is a x square minus 16 divided by x minus 4. If I plug x is equal to 4 into the function, I will get 0 over 0 form. This tells me that there is a zero factor in the top and bottom, which I need to remove. So I will factor the top, x plus 4, x minus 4, and then I will factor the bottom, which is already factored, x minus 4, and I compute the limit of this simplified version of the function. X minus 4 will cancel out, so I will get the limit. If I plug just 4 now, then I will get a finite number 8. However, what is the value of the function at 4, which is a given 10? So that means the limit of the function, if I take the limit x approaches to 4 of the function, that is not equal to, because 8 is not equal to 10, the value of the function. Therefore, the function is discontinuous. Let's do one more practice problem. In this problem, we would like to find the value of the c so that the function is continued at x is equal to 3. So I will start calculating the left limit of the function first on 3. On the left side of 3, my function is a 2x plus 9 over x. And if I plug x is equal to 3 into the function, I will get 6 plus 3, which is a 9. Now I will calculate the right limit. X approaches to 3 from the right. My function is a minus 4x plus c, where c is a constant. And if I plug 3 into my function, I will get negative 12 plus c. So in order to function be continuous, the left limit must be equal to the right limit, or in other words, 9 must be equal to 12 plus c. So that gives me c must be equal to 21. As you can see, if I take c is equal to 21 and plug it here, I will have 9. And also, if I calculate the value of the function at 3, f at 3 is basically here where you have the equality sign. If I plug 3 here, I will get 9. So the left limit is 9, right limit is 9, and the value of the function is also 9. So all these things are equal if my QC is equal to 21. So C is equal to 21 is the right value of this constant, which will make the function continuous. Here I have another quiz problem for you to practice. Pause the video for 1 and 2 minutes and work on this problem. Next, we will talk about the continued and elementary function. A function is said to be elementary if it is the addition and subtraction of the simple function, exponential, e to the power x, logarithm, constant, polynomial, trigonometry, inverse trigonometric function, or a root function. For example, if you have a polynomial function x squared plus 2 and you have a trigonometric function sine x, if you add them or subtract them with addition or multiplication or subtraction sign, the new function which will form we will call that function elementary function. Another example of elementary function here, which is the composition of a polynomial function, logarithm function, and then you subtract from exponential function, and you have on the top trigonometric function. Here is there are two elementary function. They are divide together, this elementary function over that elementary function is still an elementary function. There is a nice property of elementary function. They are continuous on their domain. So if somebody asks you to calculate the interval of the continuity of an elementary function, all you have to do is you have to calculate the domain of the function. There are some property of the continuity which are here. If two functions are continued, f and g at x is equal to c, then the constant time multiplication of a continuous function is also continuous. Addition and subtraction of two continuous function is a continuous. Multiplication of two continuous function is a continuous. The division of the two continuous function is a continuous, provided the bottom function, the denominator function, is not a 0 at that point. Here I have some elementary function, some simple elementary function and their domain listed here. Polynomial function are continuous everywhere, so their domain is minus infinity to infinity, or the interval of continuity is minus infinity to infinity. Even root function, x to the power 1/2, x to the power 1/4, x to the power 1/8, they are all even root function. They are continued every positive, so 0 to infinity. So 0 is included. They are continued every positive real number. Odd root are continuous everywhere, which is a 1/3, x to the power 1/5, and etc. And they are continuous everywhere, minus infinity to infinity. Logarithm function are continuous only positive real axis, or the interval 0 to infinity. Exponential function are continuous on this interval minus infinity to infinity. Sine and cosine function are also continued everywhere. Tangent and secant function, they are not continued at pi by 2 plus n pi, but they're continued everywhere else. And cot x and consecant x, they are not continued except n pi, but they are continued everywhere else. Here we have two elementary functions. This is the division of two polynomial function. And this is the square root of a polynomial, square root function and a polynomial function. And to find the interval of the continuity, first we have to do is, but all we have to do is we have to just calculate the domain of the function f and the domain of the function g. Since f is a rational function, the domain of this function is every real number except the root of the denominator function. So all I need to do is I need to find where this function is 0. And we will take away all these values from the interval minus infinity to infinity, or real number. To calculate the root of this polynomial, I will use the quadratic formula, which is a minus b plus minus b square minus 4ac divided by 2a. For simplification, you will get 1 plus minus square root of 6. It means 1 plus square root of 6, 1 minus square root of 6. These are the points which are not in the domain of the function, and also, so therefore, this also not in the interval of continuity. So this is the interval of continuity because this is the elementary function. What is the domain of the second function? If this is a square root of function, all we need to do is we need to check where this function is a positive, where the inside function is a positive. Because square root of function is only only domain of the square root of function is only when the inside function is positive, gives the positive value, because the square root of negative numbers are not defined. If I plug a number between 1 and square root of 6, what I have to do is basically we have to calculate the root of the inside function and then do the line test. So the root of this x square minus 2x is already calculated, which is a 1 plus minus square root of 6. If I pick a number in between 1 minus square root of 6 and 1 plus square root of 6, I will get what I will get. I will get a negative number here, and I will get a positive here and positive here. You can find any number which is greater than this and greater than this, plug into this function, you'll find. So the domain of the continuity is 1 minus square root of x and 1 plus square root of x to plus infinity. This is the continuity. The domain of the continuity of the function is. Now, so this is also the interval of the continuity because this is the elementary function. So all you need to have to do is to calculate the domain of the function if the function is elementary. Here is another property of a continuous function. If the function is continued and the composition, you want to compute the limit of the composition, you can move the limit inside if the outside function is a continuous. For example, in this question, if since the square root of function is continuous, what I can do is I can calculate the limit. I can move the limit inside of x plus 1, as well I can move the limit on the inside of e to the power x, tangent of x. This is a square root of 1 because the limit of x plus 1 is just 1, and this is a e to the power, the limit of sine x, the tangent x is 0, so you get just 1. Here I have one quiz problem for you to practice, which is also related with the continuity of the function. You are exactly 30-inch tall at some point of your life. Give me the answer in true or false. Okay, this is the end of this video. Thanks for watching. I will see you in the next video. Bye for now.